Hello everyone, welcome to the first lecture. In this lecture, we will talk about why we need to use spreadsheet applications, the terminologies that you need to know when you want to work with the spreadsheets, and how you can do calculations by entering a formula using operators or functions. After covering the basic principles, we will talk about different categories of functions such as financial, math, and statistics. And at the end, we will cover concepts related to the self-referencing and how to find formula errors. Let's start by talking about when we need to use spreadsheets. A spreadsheet is a software application for organizing and analyzing data in tabular format. These applications provide an environment for doing different calculations using built-in functions. Also, a spreadsheet can be used to draw different types of charts based on your data and perform some predictions. There are different spreadsheet applications. However, in this course, you will learn Microsoft Excel, which is one of the most popular spreadsheet applications. Excel files are called workbook, and in each workbook we can have different pages that are called worksheet. The reason that we create different worksheets in a workbook is for separating and managing data and creating different categories of information. A spreadsheet is divided into rows and columns. Rows are labeled as numbers starting at 1 and columns as letters. They start from A to Z, then AA, AB, and so on. The intersection of a row and a column is called cell, and each cell has a unique reference, which is combination of its row number and its column letter. For example, the cell which is in the intersection of row 5 and column C is called C5. The structure of Excel is similar to the other Microsoft Office products. The tools are categorized in different tabs that are called ribbon. Also, there is a part that shows the content of the cells, and it can be used to type the calculation formulas. The values that can be entered in the cells can be categorized into two categories: constants and formulas. Constants are the values that don't change. They can be textual or numerical values. Formulas are used to do different calculations on the constant values. A formula can be a combination of numerical constants, cell references, arithmetic operators, or functions. A formula can be written in three different ways. You can use the operators, functions, or combination of both. Formulas are defined by typing an equal sign. For typing a formula using the operators, you should type equal, then reference number of the cells, then the operator, and finally the other cell reference numbers. For example, here we calculated the summation of cells A1, A2, A3, and A4. There are five operators including addition, subtraction, multiplication, division, and exponentiation that can be used together or alone. When we use a combination of the operators, we should consider that there is an order for the operators. First, the values that are in the bracket will be calculated, then exponents, and after that division and multiplication, and at the end summation and subtraction. Another usage of the operators is for calculating the difference between dates. For example, here we calculated the difference between the date which is in cell A1 and the date which is in cell A2. The result is 24, which means that the difference between these two dates is 24 days. In Excel, the output of a formula can be used as an input for another formula. For example, here we calculated the multiplication of B5 and C5 and so on, and showed the results in D5 to D9. Then we calculated the summation of D5 to D9. As I said, the other way of typing a formula is using a function which simplifies creating a formula. function is a predefined computation, which is like a calculator that gets some cells numbers as the input and perform different calculations. For example, here we calculated the summation of A1, A2, A3, and A4 using a function instead of using the operators. As you can see here, we typed equal, then the function name, which is sum, then we opened the bracket and typed the cell range, and finally we closed the bracket. Please consider that for functions we type the cell range instead of all the cells numbers. Also, for defining a cell range, you should type colon between the first and the last cell. When you want to use a function, you should know its syntax and the arguments that function accepts. Argument means the inputs that you can enter into the function. It can be only one cell or a range of cells. As an instance for a function like sum that calculates the summation, as the argument we should use a range of cells. For example, from A1 to A20. But for a function like ABS that calculates the absolute value of a number, you can only use one cell as the argument. Syntax means the way that you should sort the arguments. In fact, syntax defines the format that you should use to put the arguments in the function. As you can see here, D5 to D9 range is the argument for some function. When you are typing a function, Excel provides an autocomplete feature that displays a list of functions that match letters as you type. After you type a function name and open bracket, Excel displays a function screen tip that displays the function's argument. As you can see here, for some function, summation function, we can have multiple arguments. Number 1 means one range, and number 2 means another range. When you should add more than one argument into a function, you should separate them using comma. For example, here we calculated the summation of A1 to A4 and A9 to A15 and separated the cell ranges using comma. One important point about writing formulas in Excel is that we can combine functions and operators. As you can see here, we used some function to calculate the summation of A1 to A4. Then the results are multiplied by 2. And finally, 3 is added to the result. Since it is difficult to remember the name of all the functions, we can use Formulas tab to find the desired function and typing it by just some clicks. In Formulas tab, you can find all the available functions in Excel and you can use them easily. You simply need to click the desired function category and click on the function that you need. There are different categories of functions such as financial, date, time, math, statistical, and engineering. Here we want to use the Formula tab to type the sum function again to calculate the summation of A1 to A5. In order to do this, we click Math and Tree category and click Sum function. Then in the function argument window, we should type the cell range, which is A1 to A5. As you can see, cell A10 contains sum A1 to A5. An additional method of entering a function into a cell is using the Insert Function dialog box. The easiest way to open this window is clicking Insert Function, which is located between the name box and formula bar. You can type the name of the function in the search bar or scroll through the list of functions determined by the category that you select. When a function has been selected, the syntax and a description of the function will be displayed. Watch the video in the next slide to know more about functions.
Functions are a great time-saving option for calculating data in your worksheet. They can be used in place of formulas when a formula would be too long or just too complicated to write out manually. To access the function library, go to the Formulas tab on the ribbon. Here you'll find hundreds of functions to choose from. They've all been organized into categories to make them easier to find. For example, under Financial, you'll find functions that deal with things like interest and monthly payments. Under Text, you can perform text manipulations, like converting lowercase to uppercase, replacing text, and more. Date and Time includes functions that return the current date, time, day of the week, and other useful data. Some of the most common functions are pretty simple though, like Sum and Average. You can access these using the drop-down arrow under AutoSum. In this example, I'd like to add these 10 cells to calculate the total. If I tried to create a formula for that, I'd have to add each cell individually. Not only would that be tedious, it would also make the formula really long, especially if I had, say, 100 cells that I wanted to add. So instead of creating a formula, I'm going to use a function. First, select the cell where you want the answer to appear. Then choose a function. In our case, we'll open the AutoSum menu, and then choose Sum. Now Excel has inserted the function and also selected the cells that are being added together. If it selects the wrong cells, you can always change that by dragging the corner handles here. When you're done, press Enter on your keyboard, and the answer will appear. Let's look at this function in a little more detail. Just like formulas, functions always start with an equal sign. But you may have noticed that there are no mathematical operators, such as addition or subtraction, like you would normally see in a formula. Instead, functions use a specific syntax that includes the name of the function, followed by one or more arguments in parentheses. The arguments tell the function which cells or numbers to use when calculating the result. In this example, we only have one argument, even though there are two different cell references. This is called a range of cells, or a cell range. A cell range is represented by two different cell references with a colon in between. In this case, the range consists of all the cells between D3 and D12. If you want to use more than one argument, you'll need to separate each one with a comma. Let's try a different function now. In this example, we have a column for the date that each item was ordered and the date that it was received. What I'd like to know is how many business days it took for each item to be delivered. First, select the cell where you want the function to go. Then choose a function if you know what category it's in. If you don't, you can try searching for it instead. Just click the Insert Function command on the far left of the ribbon. Searching for functions can be tricky, but for more experienced users, this can be an extremely useful tool. Just type a description of the function you're looking for. I'm looking for something that'll count the number of days that have elapsed, so I'll type count days and then press Enter. We've gotten a lot of different results here. To learn more about a function, just click the name, and a description will appear below. The function called net workdays returns the number of workdays between two dates, and that's exactly what we want. So I'm just going to click OK, and another dialog box will appear. There will be separate fields for each argument in the function. This function has up to 3 arguments: start date, end date, and holidays. When you click a field, you'll see a description of it below. And if you need more help, you can click the link that says Help on this function. For the start date, I'm going to select cell E3. And for the end date, I'll select F3. We know the holidays argument is optional because it's not in bold, so I'm going to leave that one blank. Before you continue, you can check the result of the function here. When you're ready, click OK, and the function will be added to the worksheet.
As I said, there are different categories of functions, and in the next slides, I'll make you familiar with the useful functions. The first category that I want to talk about is financial, that can be used to calculate payments, rates, and the present or future values of an investment. Here you can see a complete list of all the financial formulas. As some examples, ChemIPMT returns the cumulative interest paid between 2 periods. FV function returns the future value of an investment. IRR function returns the internal rate of return for a series of cash flows. PMT function calculates the periodic payment for a loan. NPER function returns the number of periods for an investment. FV function returns the present value of an investment, and rate function returns the interest rate per period. One of the most useful functions in the financial category is PMT, which, as I said, calculates payments for a loan with the use of 3 required arguments and 2 optional arguments. The rate argument is the interest rate per payment period. For example, if the annual interest rate is 12% and you make monthly payment, the rate will be 1%. The NPER argument is the total number of payment periods. The term of a loan is usually stated in years. So for monthly payments, the NPER is determined by multiplying the number of years by the number of payments in 1 year. And the PV argument is the present value of the loan. Please consider that the result of the PMT function is always a negative value because it represents your debt. FV and type are optional. FV indicates the future value or a cash balance you want to attain after the last payment is made. If FV is omitted, it is assumed to be 0. Finally, type indicates when payments are due. If you type 0 or you omit it, it means the due date is at the end of the period. But if you type 1, it means the due date is at the beginning of the period. Look at this example. As you can see, rate argument is calculated by dividing annual interest rate column, which is APR, by the number of payments per year. It means G9 divided by B5. The number of payments is calculated by multiplying number of years that the loan should be repayments and the number of payments per year. It means F9 multiplying by B5. Finally, as the present value of the loan, we use D9 cell. One important point, if you want to get positive value for PMT result, you should type the present value of the loan with negative sign. Watch the demo in the next slide to see how you can use PMT function in practice.
Now I put together this fairly simple example of a home loan that's for $100,000 and you're trying to purchase this home over here. Typically you don't just have a stack of money that you're bringing over to pay for the house. You usually have to go to the bank to get a loan, and let's say that loan is therefore $100,000 and today's rates are 4% per year. And the number of years that you have to pay this back is 30 years. These are always the consistent inputs to figuring out a loan, and then therefore figuring out, well, how much is your monthly payment? So let's start here just by typing the payment formula, and as you can see it pops up and says that it calculates the payment for a loan based on consistent payments and a consistent interest rate. Okay, so that makes sense that it's trying to calculate based on how a home loan operates the payment. And it needs to know the rate, the number of periods, the present value, which is all labeled right here. So present value, rate, number of periods. I've already put in the inputs. And then the future value optionally, and then the type. So the type is looking for a 0 or a 1 optionally, and then by default it'll take 0. And so 0 means that it's being paid in arrears, which means it's being paid late or paid after the period happened, and then all of this accrued interest is then being paid at the end of the period, versus being paid up front at the beginning of a month. So in a home type of a loan, it's being paid in arrears. But if you're thinking about renting a house or something like that, that's usually paid in advance. Therefore, you'd use the number 1 here at the end to signify that. So let's start here with the rate. And I'm actually going to type this a little incorrectly at the beginning just to show you some of the examples of what could go wrong and how to problem solve to fix it. So the rate right here is this amount. So I'm going to put a comma. The number of periods is 30, and the present value of the home loan today is $100,000. And again, the future value is in brackets, meaning it's optional, and same with the type. So type is default at 0, which means it's being paid at the end of the month or being paid in arrears, which is how a home loan operates. So I'm just going to close it up and hit enter. And I don't know about you, but $5,000 per month seems awfully high. And so I actually typed this in wrong, like I was saying, so that we could go back and kind of problem solve to see what's going on and why it's incorrect. So let's pop back into here using F2, and let's look back at these arguments. So the rate we're looking at first, so the rate is right here, interest rate of 4%. Well, this is a yearly rate, so we need to pay attention to what we're talking about. So this is a monthly payment, but a yearly rate, and you got to think, how often am I paying this mortgage? You're paying it monthly. So therefore, you actually have to divide that 4% into 12 different months. So you're actually not paying 4% per month. You're paying 1/12 of 4% per month. And then the same thing with the number of periods. So how many periods are there? Well, it's a 30-year loan, but the number of periods on how you're paying it is actually months. So we actually need to multiply this by 12. Dividing the rate by 12, and then you're multiplying the number of periods by 12, the present value stays the same as $100,000 because that doesn't change whatsoever. So now let's see what we get. All right, this seems much more reasonable. About $500 per $100,000 loan at 4% for 30 years. So we're only going to be paying about $500 a month. And then let's go ahead and just calculate how much money we'll be spending over the next 30 years if our monthly payment stays constant at this $500 amount. So let's multiply this times the 30 times 12. So what we're doing, we're saying, hey, this is going to be paid for the next 30 years, and there's 12 months in a year. So let's return that. You're going to be paying out of pocket $171,000 to pay back this $100,000 loan. You can easily see that $71,000 of this will be interest and the $100,000 will be principal. Now the next thing we need to do is learn how do these other formulas operate. And to do this, let's pretend like we already knew our monthly payment. So I'm just going to copy this and paste it special as a value. So this was actually an input. And let's say, here let me pop down my ribbon. So Control and F1, we'll pop it down. This is now yellow, so it's an input, but this one I'm going to delete it. Now we're going to put this as a calculation. So I'm going to say no fill. And let me hide that ribbon, Control F1, and let's start typing it. So equals PV. And you can remember that we're using PV because we want to know the present value of something. What is the value of this loan today? That's what present value means, literally present, today's value of the loan. And so we'll start with the rate just like we did before, rate here. And again, just as we did before, let's make sure that we divide it by 12 months because we're paying 12 individual payments per year. Then we're going to take the term of the loan, 30 years, and make sure we multiply that by 12 because there's 12 periods in each year. And then the payment that we've already calculated, this monthly payment, make sure that this is monthly, that you're not putting in a yearly payment. And then close it up and hit enter. And you can see the formula returns exactly what we expected, $100,000. All right, and I think this is making sense, so let's quickly go ahead and do the rate and the NPER formulas. And so to do that, let's copy this and paste it in as a value as if we had that already there. And let's put this as a formula. So I'm going to do the rate formula to figure out the rate. And just notice that it's always these same arguments. So I'm going to grab this NPER, make sure that we multiply it by 12, and then grab the payment, monthly payment that we calculated earlier, and then the present value. And then close it up. And you can see it equals 0. All right, I have no idea what's going on. Why is it 0? And the reason is it's because we're dividing it by 12, so we're actually getting a monthly rate. So therefore, this is 1/12 of the 4%. So if we times it by 12 months, we should get 4%. Okay, so now we have this. Let's just actually type this in as 4%, and then let's do NPER. So let's calculate this one. So NPER, number of periods we're calculating here. And this time it's asking for the rate first. Remember to divide this by 12, comma, the payment, which is this amount, comma, the present value. Close it up and hit enter. The same thing happens as it just did in the interest rate where it's giving us the data in months. So now we need to go ahead and divide it by 12 to get 30 years. Now the last thing we need to do to check our work is create an amortization table. So I put in the headers here, and let's start with this loan balance. So the beginning loan balance is $100,000. And we calculated that the payments are going to be $477 per month. And I'm going to lock this up with F4 because that's going to be constant for every single month. Now the thing we need to figure out now is the split between principal and interest for each payment. So it's easiest if we start with the interest because we can take the current loan balance and multiply that by 4% interest. Make sure we lock this up with F4 because that's not going anywhere, but we're going to drag it down. And then we need to then divide it by 12 because that's an annual rate and we need to divide it into a monthly rate. So then we can tab over and that says 333. So actually let's go back, F2 in it, and then put in a negative so that it comes back as an outgoing amount. Then the principal amount should just be the difference between the payment and the interest that's outgoing, and that's 144 this first month. And the new loan balance is the beginning balance plus the principal paid down. Now that we have the ending balance of that loan, we can come over here and put that in as the beginning balance and hit enter, and then we can copy this down. Actually, I'm going to paste formulas just so I don't get rid of some formatting, and then we can select all the way across and just double click it down. Now let's go down to the bottom, control down, and you can see at the very end, the last payment, 360, that's the very last payment. Our loan balance at the end is 0.
The next category of functions is logical category that can help us to check a condition or perform a comparison and do an action based on the result of the condition and the comparison. Here you can see a complete list of logical functions. In the next slides, I'll explain the commonly used functions for you. One of the most popular functions in logical category is if function that allows you to make comparisons and do an action based on the result of the comparison. The if function tests the specified criteria to see if it is true or false, then returns one value when a condition is met, or if it is true, and returns another value when the condition is not met, or if it is false. In if function, the first argument is the logical test, which contains either a value or an expression that is evaluated to see if the result is true or false. For this argument, we can use comparison operators to make the comparisons. The second argument is the result that we want to get if the condition is true, and the third argument is the result for when the condition is false. These arguments can contain text, cell references, formulas, or constants. Here you can see some examples of using if function. The first example, which is typed in cell A10, checks if the value of A2 is equal to A3. If the condition is true, it shows the value of cell A4. Otherwise, it shows the value of cell A5. The second example checks if the value of cell A3 is less than A2. If the condition is true, it shows the value of cell A4. Otherwise, it shows the value of cell A5. The third example checks if the value of cell A3 is not equal to A2. If the condition is true, it shows not equal. Otherwise, it shows equal. The fourth example checks if the value of A2 multiplied by A4 is equal to A3 multiplied by A5. If the condition is true, it shows the value of cell A6. Otherwise, it shows 0. The last example checks if the value of A2 is equal to 1000. If the condition is true, it multiplies A2 by A3. Otherwise, it divides A4 by A5. Watch the demo in the next slide to see how you can use if function in practice. There are three keywords that can be used in a function to create more complex conditions. The first one is AND, which is used to define more than one condition. As you can see in the first example, we used AND to combine these two conditions. So if B2 is greater than 75 and C2 is greater than 15, then the function shows very good. Otherwise, it shows not good. Please consider that when you use AND, both conditions should be true, and if just one of them is true and the other one is false, the condition will be considered as false. The next keyword is OR. In contrast with AND, even if one of the conditions is true, the condition result will be considered as true. The second example shows if B2 is greater than 75 or C2 is greater than 15, it shows good, otherwise it shows not good. So if only one of the conditions is true, the function shows good. The third keyword is not, which reverses the condition. As you can see in the third example, the condition is C5 less than 50, but since we used not, it means that condition is correct when C5 is greater than 50. So if C5 is less than 50, it shows FL. Otherwise, it shows PS. The third category of functions is text category that can be used to manipulate text strings by extracting a part of the text or combining words from different cells into the target cell. For example, exact function checks if two text values are identical. Find function finds one text value within another. Left function returns the leftmost characters from a text value, and replace function replace characters within a text. Text join function combines the text from multiple ranges, and trim function removes spaces from a text. Let's talk about the useful text functions in detail. As I said, text join is one of the useful functions in the text category that can be used to merge the values of different cells into the one cell. This function has four arguments. The first one is delimiter, that is used to define a character that we want to apply as a separator between the words that will be merged from different cells. For the second argument, you can type true or false. If you type true, it means that Excel will ignore the empty cells, but if you type false, Excel merge the empty cells as well. So it's better to leave it true. And the third argument is the cells range that you want to use in order to merge their contents. Left is another useful function in the text category that is used to extract a part of a text from its left-hand side. For example, you can extract the first four characters of a word and show the result in another cell. In order to use this function, you should type equal left, then you should type the text or the cell name that you want to extract some of its characters. Then in the second argument, type the number of characters that you want to extract. As you can see in this example, we extracted the first three characters of New York City, and the result is new. Exact function is used to compare two texts, and it only returns true or false. If the two texts are equal, the result is true, but if they are not equal, the result is false. In order to use this function, you should type equal exact, then as the first argument, type the first text, or you should type the name of a cell that contains your text. And as the second argument, type the second text or the name of the second cell that you want to compare with the first cell. Please consider that this function is case sensitive. It is very important. It means that if you have two words but you typed one of them with the small letters and the other one with capital letters, they will be considered as two different words. The last function that we want to discuss in the text category is called replace, which is used to replace a part of a text. In order to use this function, you should type equal replace. As the first argument, type the original text that you want to replace a part of that, or the cell name that contains your text. As the second argument, type the starting location in the text that you want to replace. In the third argument, type the number of characters that you want to replace. And as the fourth argument, type the new content that should be replaced with the original content. For example, here we used replace formula to replace the content of cell B5. We stated that we want to start from the fifth character, and we want to replace 4 characters with a new content, which is 2018. So we replace 2017 with 2018. The fourth category of functions is date and time. These functions can be used to perform different calculations on date and time or return a part of them. For example, dative function calculates the number of days, months, or years between two dates, and network days function returns the number of working days between two dates. Now function shows the current date and time. Year function extracts the year from a date value, and weekday function shows the weekday of date. Dative function is one of the most useful functions in date and time category. It can be used to calculate the difference between two days based on different units such as day, month, and year. In order to use this function, type equal dative, then as the first argument type the start date or the cell name that contains the start date. As the second argument, type a cell that contains the end date. And as the unit argument, type Y if you want to calculate the difference based on year, type M for calculating the difference based on month, and type D to do the calculation based on the number of days between two dates. As you can see here, we calculated the year difference between the date which is entered in cell B5 and the date that is entered in cell C5. Please consider that the start date should be smaller than the end date. Otherwise, Excel shows an error message. The other useful functions are now and today. With the use of now, you can return the current date and time, and with the use of today, you can just return the current date. One important point about now and today is that they will be updated by reopening the workbook. I mean, every time that you open your workbook, the cell value will be updated based on the current date of your computer. These functions can be used in the other date and time functions as well. For example, we can use them as the end date in date and time to calculate the difference between the current date and another date. As you can see here, we calculated the difference between today's date and the date which is entered in cell A1. There are a group of functions in date and time category that can be used to extract a part of a date. For example, with the use of year function, we can extract the year part of a date. For using this function, type equal year and type a date or the cell name that contains the date. The last function that we want to discuss in date and time category is called network days. With the use of this function, we can calculate the working days between two dates. In fact, this function can understand the weekends and then it deducts the weekends and shows the days between two dates. In order to use this function, type equal network days, then as the first argument type the start date, As the second argument, type the end date or a cell that contains a date value. If you want to add holidays, you can use the third argument, which is optional. If you add the holidays, they will be deducted from the days between 2 days in addition to the weekends. The fifth category of functions is lookup and reference functions that can be used to find a value, fill a table based on the value of another table, create link to the cells, or provide reference to cells in a worksheet. The most useful functions in this category are lookup and are VLOOKUP and HLOOKUP functions that will be explained in the next slides. VLOOKUP function accepts a value and looks for the value in the left column of a specified table and returns another value located in the same row from a specified column. The first argument of this function is lookup value, which is the cell reference that contains the value to look up. In this example, it is C5. The second argument is the range that contains the lookup table, which is in this example G5 to H10. The third argument is column index number, that is the column number in the lookup table that contains the return values, which is 2 in our example. The last argument is range lookup, that is optional. This argument determines how the VLOOKUP function handles lookup values that are not an exact match for the data in the lookup table. Here you can see another example of using VLOOKUP. In this example, we want to find the grade of students based on their marks. We want to know if they got high distinction, distinction credit, pass, or fail based on their mark. We have two different tables here. The first one shows grading scale of the university, and the second table shows the mark of the students. The green table shows the marks of the students, and the orange table shows the grading system of the university. As the first argument, we use the cell that contains a student mark. As the second argument, we use the grading scale table. And as the third argument, we type 2, which means that we want to have the value of the second column of the grading scale table. For example, James got 85, so his grade is HD. Jessica got 76, so her grade is distinction. Watch the next slide demo for an additional example.
The tables in the spreadsheet have some of the most famous runners in the world, including Usain Bolt, the world champion. The runners are numbered from 1 to 10 in column B. The numbers are for illustrative purposes only. The names of the runners are in column C. It is important to note that the tables on the left-hand side are set in ascending numerical order from 1 to 10. However, the table on the right-hand side is arranged in alphabetical order, using the names of the athletes. So, the numbers in that table are not in ascending order. We use the VLOOKUP function to get the prize money each athlete has won in column J in the second table into column D in the first table. Step 1. First, click into cell D2, as this is where we want the first VLOOKUP result to appear. Step 2. Click on the FX button above column B. Many people start by typing equals VLOOKUP, but you don't have to. Clicking the FX button is much quicker. When you click the FX button, you will see the Insert Function table pop up. From this window, we will select the VLOOKUP function, as it is one of the most recently used functions in the category. If the VLOOKUP function is not listed as one of the most recently used functions, then change the or select a category field to all, then scroll to the bottom, where you will see the word VLOOKUP. Once you find the VLOOKUP option, you can simply click on it. Click OK, and the Function Arguments window will pop up. This table will show the syntax, which is a fancy word for the format of the formula, and it will display the different parts of the syntax. In this case, the syntax is VLOOKUP, parentheses, lookup value, table array, call index, num range, lookup. Step 3. Here, you should click into cell B2, because that's the first number or reference for which you want to look up a value. The lookup value is for the corresponding value we want to find in the first column of the second table. So, we want to find out what prize money the runner in position 1 got in the table that spans columns H to J. Step 4. Now click in the next field, the Table Array field. A table array consists of 2 or more columns of data in the first column in the table array. In this case, column H has the corresponding numbers that the lookup value is looking at. In other words, the runner positions in this example. Step 5. After clicking in the table array field, you then need to highlight the columns that you want to look up the data from. Here, we will highlight columns H to J because our lookup value column starts from column H in the second table, and the prize money which we want to check is in column J. An alternative way to populate the table array field is to highlight the range of data you're looking up, starting with your first unique value, in this case, cell H2. So, you'd highlight cells H2 to J11 because J11 is the last cell in the range. You then need to fix this table array by putting $signs in before the H, before the 2, before the J, and before the 11. So your formula at the end looks like this: equals VLOOKUP, parentheses B2, $H, $2, $J, $11, 3, false. If you're in the table array field and you press F4 on your keyboard, Excel will do this automatically for you. This is useful to know if the spreadsheet doesn't allow you to highlight cells H to J because some cells are merged or you're getting an invalid error. But for now, just leave it, ensure your fields look the same as those in the screenshot above, and then proceed to Step 6. Step 6. When you highlight the columns, you should note that column J is the third column from column H. We then move on to the next step, call index num, which is the column index number. Click on that field and type the number 3. This is because column J is 3 columns away from column H. Step 7. Now, for the last step, simply click in the range lookup field and type in the word false. You should always type in the word false here because we want the VLOOKUP to return an exact match for what we're looking for, and if it doesn't, we want it to return the word false. Now click OK, and like magic, you will notice that the VLOOKUP has returned a figure of $1 million beside Usain Bolt's name in the first table. If you look at the second table, the figure of $1 million is also against Usain Bolt's name, so we know the VLOOKUP has worked. And that's how you string together the VLOOKUP formula in Excel. Now all you have to do is drag down the formula so that the cells below cell D2 populate, and you save yourself the hassle of manually finding the corresponding prize money value for each and every athlete in the first table. In a work scenario, if you had hundreds of rows of data, this would literally save you hours of work.
HLOOKUP function is similar to VLOOKUP, but instead of retrieving data from a column, it retrieves data from a specific row. As you can see in this example, we have a table with some basic information about the planets of our solar system. We want to get the diameter of the planet whose name is entered in cell B5. In our HLOOKUP function, we entered B5 as the first argument, which is the cell containing the planet name that you want to find its diameter. For table array argument, we entered B2 to I3, that is the table where the function will look up the value. In row index num argument, we type 2 because diameter is in the second row in the table. And that's it. The video in the next slide shows another example of HLOOKUP. Watch it for more info.
And you can see here, I've got a table with a list of my shipping rates. I've got 4 regions here and 4 different shipping rates for each one of those regions. And what I want to do is I want to look up the proper shipping rate based upon the value here in column C and return that. So I want to match the value in column C to the first row in my lookup table, and I want to return the second row in my lookup table. So let's go ahead and click on cell D2, and I'm going to type in equals HLOOKUP, parentheses. Now again, the first value you enter in is the value you wish to look up. So I'll go ahead and click that cell right there, cell C2. And then I'm going to type a comma, and the next thing we enter in is the lookup table. Now the first row in the lookup table has to be the row that you're comparing the lookup value to. In this case, I'm looking up the region. So the first row needs to be row 10. So I selected B10 to E11. Again, the first row will be the row it looks up the value in. When it finds a matching value, in this case the value would be north, I want it to return the second row inside of my lookup table. I could have different values here depending on what I'm exactly doing in my table. So I could have it return the value in the third row of the table, the fifth row of the table, the 20th row of the table. It doesn't matter. And then I'm going to go ahead and close my parentheses. And I'm actually going to go ahead and highlight these values here and press F4 on my keyboard to make them absolute values. That way I can autofill the value down. So I'll go ahead and hit enter, and you'll see that it looked up west and found a shipping rate of 3%. And I go over here to west, and it's returning the value 3%. I'll go ahead and autofill that down, and there I have the different shipping rates looked up based on this table here. You can see if I change a value, for instance, I'm going to change 5% here to 10%, my orders table adjusts accordingly, and all the calculations recalculate.
The fifth category of functions is math and trig that is used to perform different standard math and trig calculations, such as calculating sine, tangent, and cosine of the given angle, rounds a number, matrix of an array, or logarithm of a number. Some of the useful functions in this category are ABS, aton, sine, mean-verse, and log. ABS function returns the absolute value of a number, and aton function returns the arctangent of a number. Mean-verse function returns the matrix inverse of an array, and log function returns the logarithm of a number to a specified base. Round function rounds a number to a specified number of digits, and round down function rounds a number down towards 0. And sine function returns the sine of the given angle. Here you can see an example of using math and trig category functions. We use sine function to calculate the sine of 30-degree angle. When we need to supply an angle to sine function in degree, we should convert it to radians by multiplying the angle by p divided by 180. Also, we can use the radians function to convert to radians. Logarithm function can be used to calculate the logarithm of a number. By default, this function uses 10 as the base of the logarithm, but you can use any value as the base. As you can see in this example, we calculated the logarithm for different numbers with the use of different bases. Round function is used to round a number based on the given digits. As the first argument, you should type your number or the cell that contains your number. And as the second argument, you should type the number of digits that the number should be rounded to. If the number of digits is greater than 0, the number will be rounded to the nearest decimal. For example, if you type 2 for the second argument for a number like 5.7845, the second decimal digit will be rounded and the result will be 5.75. But if the number of digits is negative value, the number will be rounded to the nearest integer. The seventh category of functions is a statistical that is used to perform simple and complex statistical calculations. Simple such as average and standard deviation, and complex such as probability, variance, and geometric mean. For example, count function counts how many numbers are in the list of arguments. correl function returns the correlation coefficient between two data sets. FDIST function returns the F probability distribution. DevSQ function returns the sum of squares of deviations. Geomean function returns the geometric mean, and gamma Pierce function returns the natural logarithm of the gamma function. And finally, varp function calculates variance based on the entire population. As you can see in this slide, we use some statistical functions to do different calculations. For example, we used average function to calculate the average of A2 to A15. We also use mean and max to find the smallest and the largest number from A2 to A15. Finally, as you can see, we used a couple of count functions. The first count function just count the cells that their value is number. Count A, count all the cells, and it doesn't matter if there is a number or text inside them. And count blank, count the number of blank cells in the range. There are three useful functions in math and statistical category called COUNTIF, SUMIF, and AVERAGEIF that can perform the calculations based on a condition. For example, COUNTIF only counts the cells that meet a specific criteria. Watch the video in the next slide to know more about these functions.
We might want to know how many full-time people work here. We could do this by way of a pivot table or possibly a more complex formula, but COUNTIF works quickly and easily. Equal COUNTIF. I'm using this in cell K2, and we're looking in column D for these entries, comma. And what are we looking for? Full-time. Now, if we don't have this in a nearby cell, I do in cell L2, but if we don't, we would type double quote, full, space, time, double quote, press enter, we get an answer. Since it's in a nearby cell, we'll just refer to that. Enter, we have our answer. And we can double click here to copy this down into the next three cells as well too. So in all cases here, we have a count of how many hourly people we have, how many contract people, half-time and full-time, quickly and easily. Occasionally, you might want to use this feature with wildcards. It would be probably unlikely you would want to total the full-time and half-time people. You could see what that total is right there. It's 489. But if we were doing this in an isolated case, we could type equal COUNTIF, left parenthesis. We'd be looking in column D, comma, and then double quote asterisk time. Asterisk is a wildcard, meaning any number of characters preceding the word time, and then a double quote, and there's our total, 489. By highlighting these two cells, we see the total at the bottom, that's 489. So in effect, we're doing the same kind of thing here, but in a different way. A similar use might be, we're looking at our list over there, we're just kind of curious. How many of these entries contain the letters TIM? Like in Timothy here, and maybe there's some Tims. We've got a few Timothys perhaps popping up. How many of those do we have? In that case, Tim is preceded by text. It's also followed by text. So in this example here, if we're doing a quick COUNTIF, we're looking in column A, comma, and then within double quotes, it's asterisk, TIM, asterisk, double quote, and then we're done. There are 9 of them. And we can verify that with a quick use of filter. Just clicking within the data, use a filter, and then jumping into column A, simply in the search panel here, type TIM and press enter. And there's our list of all the Tims. There's actually one single Tim and a lot of Timothys. But we've got 9 entries there, and that's exactly what we found in our previous example. So getting rid of the filter, going back to normal here, and viewing this once again. The asterisk on either side means Tim preceded by and or followed by any number of different characters. So you can also use this function in a more expansive way using wildcard type symbols. Now, the companion to COUNTIF is called SUMIF. The idea with SUMIF is we might start off in the same way. In other words, we're looking for people who are full-time. But SUMIF has an additional argument, a third argument that allows us to say, in effect, once we've found the full-time people, comma, Let's go get their salaries and add them. In other words, what are we spending on salaries for full-time people? We're looking in column D to see how many of those entries are full-time. That comes out of cell L2 here. And when we do find an entry that's full-time, we go to column H, take that value. Let's add up the full-time salaries. There they are. And we'll simply double-click to copy it down there. There are the salaries. We look at the bottom of the screen in the status bar, 41,653,876. And we should see the same number if we click column H. And there it is, identical. Keep in mind the status bar will vary if you right-click it and possibly check or uncheck some of the options found in this section here. I tend to leave them all checked. I don't always need them all, but anytime you highlight 2 or more cells, and that includes if you highlight a column, you will get totals at the bottom, and it's real handy at times to do cross-verification. So getting back to SUMIF, for years in prior versions, there was a SUMIF, there was a COUNTIF, but no average if. And a lot of users kept saying, give us average if. Finally, they have. If you don't have an average if, you've got to take SUMIF and divide it by COUNTIF. But it certainly is a lot more straightforward here to say, in effect, let's get the average of salaries for full-time people. And there it is. And here too, double-clicking will get the average salary for our other kinds of entries as well. And so the example here in column K, right here, average if, remember cell L2 has the text full-time. If the entry in column D is full-time, then let's go to column H, and what are we going to do? Average all of those salaries. So we can see how COUNTIF, SUMIF, and average if give us easy ways to tabulate data from lists like this without having to sort the data or rearrange it in any way.
The 8th category of functions is engineering functions that perform the most commonly used engineering calculations, such as converting different units to each other or performing calculations on complex numbers. Complex number means a number which is composed of a real number that is combined with an imaginary number. For example, bin to des function converts a binary number to hexadecimal, or bit XOR function shows a bitwise of 2 numbers. imcot function returns the cotangent of a complex number, or imexp function returns the exponential of a complex number. One of the most useful functions in this category is called convert, that can be used to convert different units to each other, such as distance, time, speed, width, area, liquid, force, pressure, temperature, energy, and power. In order to use this function, you should type equal convert. Then as the first argument, you should enter the name of a cell or type a value. As the second argument, you should type abbreviation of the original unit between double quotation. And as the third argument, you should type the unit that you want to convert to. You should also know the keywords that you should use for the unit. Another example from engineering category is imaginary function, which is used to extract the imaginary part of a complex number. For example, in cell A1, we have 5 plus 2i. The imaginary part is 2. As you can see here, the function shows 2 in cell B1, which is the imaginary part of cell A1. The third example shows 0 in cell B3, as the argument of the formula doesn't have any imaginary part. Cube functions are the 9th category of the functions that are used for data analysis when you use external data sources such as SQL. Therefore, you can't use them for data analysis when your data is entered in Excel worksheets. These functions can be used to summarize information from the raw data sources and perform most of the heavy-duty calculations on the server. The main benefit of these functions is that since they use external data sources, you don't need to spend so much time consolidating data in Excel from the other external data sources. The 10th category of functions is information category that can be used to get information about the contents of a cell. They typically displaying true or false if the cell contains a specific data type. For example, isBlank function shows true if the cell is blank. IsOdd function shows true if the number is odd. And isText function returns true if the value of a cell is text and not number. In this slide, you can see, for examples of using information functions. The first one checks if cell A2 is blank. As you can see, the result is false because in cell A2 there is a text. The second function checks if a textual value is typed in cell A3. Since we have a text in this cell, it shows true. The third function checks if the value in cell A4 is an even number. Since it's even, it shows true. Finally, the fourth function checks if the value of cell A3 is a number. Since it is a text, it shows false. Web category is the 11th category, and it can be used to return a web address or a specific data from a web service or XML code. And finally, the last category is compatibility, that contains functions that are compatible with Excel 2007 and earlier. In Excel 2010 or later, these functions were replaced with new functions that provide improved accuracy and have better names that reflect their usage. You can still use them for compatibility with earlier version of Excel. But if backward compatibility is not important for you, you should start using the new functions instead. That's it. Now you're familiar with all categories of Excel functions. Now let's talk about range name. Excel provides a feature to facilitate entering cells in formulas, which is called range. With the use of range, we can select a group of cells, then allocate a name to those cells, and afterwards, instead of typing the cells in the formulas, we can just type the name that we allocated to that group of cells. In fact, range is a reusable group of cells that can be used in different formulas. We define it once, but we can use it for multiple times. In order to create a new range, select the cell range, then go to the Formulas tab, click Name Managers, and click New. Watch the next slide demo to see how you can create a name range.
A typical spreadsheet can have lots of different cell references, and because these references are sort of generic, it can make formulas difficult to read and understand at a glance. But you can also add a more descriptive, intuitive name to any range, and then use those named ranges in your formulas. In this example, I have a tax rate in cell C2, and it's likely that we'll want to use this tax rate in other parts of the workbook. So this would be a great place to add a named range to make it easier to reference this cell. To get started, select the cell or cell range that you want to name, then locate the name box to the left of the formula bar, click it, then type a name that will be relevant and easy to remember. We'll call it tax rate. And we'll keep it all one word because spaces aren't allowed in names. Then press Enter to save the name. Now that we've named our cell, let's use it in a formula. I'm going to switch over to the menu order sheet. And in cell D12, I want to multiply the subtotal by the tax rate. So we'll type equals D11 times tax rate. And the name may actually pop up before you finish typing. So you can just press the Tab key and it will automatically insert the full name. So you can see that this formula is very simple and easy to read because we used a named range. Anyone who uses this spreadsheet will be able to see at a glance that we're using the tax rate. For comparison, here's what it would look like with a traditional cell reference. Here it may not be as obvious what that second cell reference is doing, which makes the whole formula less intuitive. If you ever need to change a named range, just go to the Formulas tab and click Name Manager. You'll see a list of all of the names in the workbook, as well as some tools to edit or delete the names. So if there are any important cells or cell ranges in your spreadsheets, you might want to consider turning them into named ranges. It can really simplify your formulas and make them easier to write and read.
Another feature that can facilitate typing formulas is autofill. This feature can help you to copy the same formula in different cells and adjust the cells in the formula based on its new location. Autofill also can complete a sequence of words or values from one cell to another. For example, we can use autofill to enter months in the cells by just typing January in one cell and using drag and drop to fill the other cells with the name of other months. Also, autofill can be used to enter numbers based on a specific sequence. For example, we can type 1 in cell A1 and 3 in cell B2, then use autofill to fill the other cells with the numbers that follow this sequence. It means 5, 7, 9, 11, and so on. As I said, one of the usage of autofill is for typing formulas. For example, if we have a formula in cell C1 to calculate the summation of A1 and B1, we can use autofill to type this formula for the other cells and calculate the summation for A2 and B2, for A3 and B3, and so on. In fact, autofill can save time by typing the desired contents for us. Watch the video demo on the next slide to know more about autofill.
Let's say we want to create a series of numbers from 1 to 13 here. To do that, follow these steps. Type in number 1, then number 2 right below, so that Excel could identify the pattern for the series we want to create. Select these two cells and drag the bottom right-hand corner of the selected area down. This way, you can create as long a series as you need. The most common problem you may encounter is that you fill in only one number, for example, number 1. When you drag the corner of this cell, Excel will not create a series, but only copy the number 1 to all cells you select. But it's never too late to fix this. If you want to turn this column of 1s into a number series, you don't need to delete anything. Simply roll out the autofill options menu down here in the bottom right-hand corner and use it to swap the options from copy cells to fill series, which will change the column of 1s into a number series. Beside these two options, there are also other items, but don't worry about these right now. We're focusing here on a number series, so we'll select Fill Series. The selected cells in the column will populate with the desired values. Such series can be created vertically as well as horizontally. But that's not everything Excel can do with autofill. You can create all the types of series you need. For example, if you want to use the series of even numbers only, we must type in 2 and 4 to start the series, and then we can autofill the rest. But that's not all. You can create the series of month names in full or their short versions, days of the week, dates, expressions ending in a number which should increase, quarters, or anything with a pattern.
When we want to use autofill, we should define the cells that are in the formula as absolute or relative. Absolute means that the cell will remain the same in the formula when we use autofill. Relative means that the cell will be adjusted by autofill. For defining a cell as absolute, we should type $sign before the column name and the row number. Absolute and relative references can be mixed together, which is called mixed reference. In mixed reference, we can make row or the column absolute and make the other one relative. For example, if we make the column of cell A1 absolute and use autofill, the row will be altered during copy, but the column won't change. There is another type of referencing called circular reference, which means that you want to use the result of a formula as an input for that formula, as you can see in this example. When you need to use the cells from another worksheet into a formula in the worksheet that you work on, you can link them. By linking cells, when you change the data in the source worksheet, the data of the destination cell will be updated automatically. In order to link a cell from another worksheet to your active worksheet, you should type the name of the worksheet first, then type an exclamation mark, and finally type the cell name. Cell referencing between worksheets can also be used to create 3D references. A 3D reference means using the same cells on multiple worksheets with the same structure to calculate data across those worksheets. In order to add a 3D formula, type the equal sign, enter the function's name, and open a bracket, then type the first worksheet name, then column followed by the second worksheet name. Finally, type the cell or range of cells that you want to calculate. For example, here we typed a 3D formula to calculate the summation of cells B2 to B5 across 4 worksheets. Similar to the linking worksheet, you can link different workbooks so that by updating the values in the original workbook, the linked cells in the active workbook are updated automatically. The steps are similar to the linking worksheet. However, before typing the worksheet name, you should type the workbook address and its name between a square bracket. The next slide shows a demo of different types of references.
There are two main types of cell references in Excel, relative and absolute. Both behave differently when copied to other cells, either as part of a formula or a function. Relative references are the default and probably the type you're going to use for most of your formulas. In this example, I need to know the total cost of each menu item on the invoice. To do this, I'll need to multiply the values in these two cells. I'll just enter my formula here. Start by typing the equal sign, and then the formula will be B4 times C4. When you're done, press Enter on your keyboard. Now if I use the fill handle to copy this formula to all of these cells, we can double-click each copy and see that the cell references have changed automatically. So we have B5, B6, B7, and so on. That's because these are relative references. In other words, when Excel looks at our original formula, what it actually sees is the location of the cells relative to the location of the formula. That means in this case, it's looking at the two cells to the left of our current location, and those just happen to be B4 and C4. Each copy is also looking at the two cells to the left of the formula. This technique is useful because it means we can copy the formula as we did here, and the cell references will sort of move along with it. The references don't even have to be in the same row. They can be anywhere in the sheet. There may be times when you don't want the cell references to change. Take this version of the invoice. I've added a column where we can list the sales tax for each item. We should be able to enter our formula here, then copy it to the rest of the list. To get started, I'm going to enter B4 times C4 in parentheses. Then I'm going to multiply by cell E2, which contains our tax rate at 7.5%, which is the same as 0.075. Next, I'll use the fill handle to copy the formula to the rest of these cells. But wait, that doesn't look right at all. It's even affecting the formulas in the rest of the worksheet. The first copy of our formula is correct because it's multiplying by E2, which contains our tax rate. But as we go down the list, we can see that the reference is moving in relation to the cells, which isn't what we want. We want it to stay frozen on E2 for each copy of the formula, and for that, we'll need to use an absolute reference. Absolute references have a $sign placed before the column, row, or both to keep them from changing when you copy the formula to another cell. To keep the column and the row from changing, place a $sign in front of both. To keep only the row from changing, place a $sign in front of the row only. To keep only the column from changing, place a $sign in front of the column. Most of the time, you'll be using the first type of absolute reference, the one where there's a $sign before the column and the row. Let's go back to our example and add $signs before the column and the row to make E2 an absolute reference. Now if we copy the formula to the rest of this list, the errors go away and we're left with the correct sales tax for each item. The relative reference is different in each cell, but the E2 reference, our absolute reference, stays the same. Finally, I'd like to show you how to create cell references across different worksheets in the same workbook. This can be useful if you want to create a formula on one worksheet that references a value from another. It works the same as a normal reference. You just have to include the name of the worksheet along with the cell address. So to get started, figure out what cell you want to use, then take note of its location. In this example, we're going to use cell E14 on the worksheet menu order. Next, switch to the worksheet where you want to use the reference. As you can see, I already have a formula that's calculating the total of all these services. I just need to add the total for the menu order in this cell here. To reference the cell, type the name of the worksheet first, then an exclamation point, and finally the cell address. If the worksheet name includes a space, like in this example, you'll need to add single quotation marks around the name. When you're done, press Enter, and Excel will pull the value from the other worksheet. That means if cell E14 ever changes on the menu order worksheet, it'll be updated here too. Mastering cell references is the key to creating formulas that work for you and your data. Now you know how to use relative references, absolute references, and references across multiple worksheets.
When you create a formula in Excel that contains an error or a reference problem, Excel lets you know about it with an error message. An error will be appeared in a cell when a formula or function can't be resolved. You can see a list of error codes in this table. We have different error messages: div, NA, that stands for not applicable, name, null, num, ref, and value. You can read them yourself. When you need to find the reason of an error in a formula, or to make sure that a formula uses correct range of cells, you can use auditing and debugging features. Excel provides a group of features for testing and debugging formulas that can help you to find the errors in your formula. The first useful feature in this category is called trace. There are two types of traces: trace precedence and trace dependence. If you want to see the cells that are used in your formula, you should click your formula cell and click trace precedence. But if you want to check if a cell is used in any of the formulas, you should click that cell and click trace dependence. If you want to see all the formulas on your worksheet to trace them, you should go to the Formulas tab and click Show Formulas button. Watch the next slide demo to see how you should use the trace feature.
There were promotions in some states during some months, but we currently don't know which states or months were selected. The formula calculating the sum of sales in the regions covered by promotion comes back with an error. We need to find out in which states and in which months the promotions happened, and how we can correct that error. Select the cell with the formula, in our case cell G25, and under the Formulas tab, select Trace Precedence. Clicking on this displays the arrows connecting the formula with all the cells it's taking data from. We now not only know which data the formula uses, but also which data caused the error. That one is marked with a red arrow. Trace precedence and trace dependence are most commonly used to understand formulas created by others, to find the source of an error, to find the reasons for circular references, and to check whether the data you want to delete is used elsewhere in the worksheet. To remove the arrows, click on Remove Arrows. A similar result to formula auditing is obtained by double-clicking on the cell containing the formula. This time, the cells that the formula uses are marked with colored rectangles. This method only allows you to view the precedence of the first level, which means only the cells directly influencing the result of the formula. This solution does have an advantage. It's easy to modify the formula by dragging one of the rectangles to a different cell. Example 2. In this example, we'll activate the cell with the sum of the sales for branches 1 to 7, cell C9, and click Trace Precedence twice. Looking at the arrows, we can see that the sum, 1039, is the result of adding the sales from the 4 cells above and an unknown number of references to other sheets in the same or another file. These references are marked by a dashed line leading to the worksheet symbol. In our example, the cells refer to data from one file, which can be seen in the formula bar. If there were more references, it would look the same, also shown with only one symbol. The second level contains the cells with the sales data for the products from branch 7 in row 3 of this worksheet. Both the Trace Precedence and Trace Dependence tools allow you to check multiple levels of connections between cells. Now use the Remove Arrows tool and check the cells that depend on cell G9 by double-clicking on Trace Dependence. The data in cell C9 is used by cell E13, which is used by cell G13 and a cell or cells from another sheet or sheets in another Excel file that is currently open. You can see it's shown here with a spreadsheet symbol. This tool won't show any dependents if they are in a closed Excel file. Let's now focus on cell G13. It seems that it's the result of unnecessary calculations and should be deleted. Before we delete it, we'll check to see whether this data is used by other formulas. First remove the arrows, then activate cell G13 and click Trace Dependence. In our case, a message has popped up saying the Trace Dependence command found no formulas that refer to the active cell, so we can now delete it and be certain. Example 3. In the worksheet Formula Auditing 3, in the bottom left-hand corner, it says Circular References G13. This means that the formula refers to itself, which is like saying someone is 5 years older than they were 5 years ago. From this riddle you can't guess the age of the person, and likewise Excel cannot solve circular references. The difference, though, is that circular references are usually a little more complicated. In some cases, Excel automatically displays arrows which show where circular references are. If they are not shown automatically, you should activate the cell containing a circular reference and click Trace Dependence until it shows a full circle where the arrows return to the active cell. The profit in 2019, in cell G11, depends on the sales in 2019, in cell G13, which makes sense. The profit change, in cell H11, must depend on the profit in 2019, cell G11. The next connection is the one we are looking for. It doesn't make sense that the change of sales depends on the change of profit. The sequence should be reversed, and the formula in cell H13 should be corrected. If we make a mistake and loop the formulas in Excel, the program will inform us about circular references and the dependency errors will be displayed. The method about correcting errors applies to situations when someone has ignored the automatic Excel warning.
Another useful feature that can be used to test the long formulas and make sure that they work properly is Evaluate Formula feature. In order to use this feature, click the cell that contains a formula and click Evaluate Formula from the Formulas tab. By clicking on Evaluate Formula button, Excel opens Evaluate window and shows the formula. By clicking on the Evaluate button, Excel solves the formula in a step-by-step manner, which can help you to understand if the formula works correctly and if you entered correct cells into your formula. The next slide demo shows how you can use this feature in practice.
Excel has a handy feature called Evaluate Formula, which solves the formula one step at a time. Each time you click the Evaluate button, Excel will solve the underlined part of the formula and show you the result. Here's the same worksheet we looked at in a previous video when we talked about debugging formulas using the F9 key. The age column contains a formula that calculates age from birth date, and the status column uses the if function to label each person in the list as either an adult or minor. Let's use the Evaluate feature to see how these formulas work. You can find Evaluate Formula on the Formulas tab of the ribbon in the Formula Auditing group. To use Evaluate Formula, select a formula and click the button in the ribbon. When the window opens, you'll see the formula displayed in a text box with an Evaluate button below. One part of the formula will be underlined. This is the part currently under evaluation. In this case, solving the today function is the first step in solving this formula. When we click Evaluate, the today function is evaluated and returns a date in Excel's serial number format, and the year frac function is underlined as the next step in the evaluation process. On the next click, the year frac function is evaluated, and the int function is underlined. One last click, and the formula is solved with a result of 12. Notice that the Evaluate button changes to Restart at the end of the evaluate process. Click Restart to evaluate the formula again. Now let's evaluate the status formula. In this case, E5 is solved first to get age, which is used in the logical test of the if statement. 12 is less than 20, so false is the result of the logical test. Minor is the final result, since minor is given as the value to use if false. Let's restart the evaluation and look at the Step In and Step Out feature. In this case, because E5 is itself a formula, we can step in and evaluate that formula too. The process is the same as a normal evaluation. When done, click Step Out to continue evaluating the original formula. The ability to step into other formulas is an optional feature. It's available when the formula refers to other formulas or to cell references. If you step into another formula and decide you don't want to evaluate it, just click Step Out to continue evaluating the main formula. So there you have it. Evaluate Formula is a handy complement to using the F9 key, and it's a great way to understand how Excel solves formulas.
That's it for this week's lecture. Hope you could learn how you should write formulas and use functions in Excel. If you have any problem or any question, you can ask your tutor in the second hour of your tutorial, or you can post it on the course forum as well. See you next week.